Rachel. Hello, Rachel. We are on 72. We are rocking right through this review. 72. I think we have to go to 96, right?
96.
96.
And then
Okay. And then we've got a couple more. Okay. So we really don't have that much left. We did a good chunk yesterday. Okay. Okay.
There's still a good
72. 72. Find the reference angle. Reference angle means the bow tie angle. You know what I'm talking about with the bow tie angle? Okay. So 635 degrees. Let's figure out what he is in like,
360.
let's subtract 360, right? Like kind of like we subtract 2 pi, but this is in degrees, so we're going to subtract 360. That is, I don't know.
275.
275?
Yep.
Okay, 275 degrees is in what quadrant?
Third.
The third.
No,
Okay.
Fourth.
Oh, man. Fourth quadrant, you're right. Fourth quadrant, right here, like this. Okay? Oh, man, this is hard to draw. So I got him down like this, and then they're like that. There's my 90-degree angle. So I want to know how many degrees this guy is. So all the way around would be 360 degrees, agreed?
Minus
But I'm
275.
only going this far. So what would be the rest of the way? 85 degrees. Really, 275 is 5 degrees on this side of that line, right? So if I'm doing that angle, that would be 85 degrees. 85 degrees is my reference angle. That's what you want.
So you could just do 360 minus 275.
Yes, yes, in that case. Now, if it's in the second quadrant, you wouldn't be able to do 360 minus, right? It would be 180 plus that angle. No. It would be,
270?
yeah, so like, example, if you are in the second quadrant, I'll do it as second quadrant. Let's say you have like 200 degrees, right? So from here to here is 200. Third quadrant, 300 degrees. From here to here is 180, not 300, 200 degrees. 200 degrees, this would be like 20 degrees. 20 degrees for a reference cycle, right? Okay. If you're in the second quadrant, like here, like well, let's say 150. 150 is here. This angle right here would be 30, right? To make the rest of the way to 180. What happens if you're in the first quadrant? Like 52 degrees. It's its own reference angle. If you're in the first quadrant, you don't have to do anything funny, right? Okay? That was a lot of stuff all at once. Good? Okay, 76. Is that the next one, but we don't have to do 80? Just 76?
76 is easy.
76 is easy. Evaluate the sine, cosine, and tangent of the angle without using a calculator. Sine, cosine, and tangent of pi over 4. When I say without using a calculator, I do say that on the test. Without using a calculator, that means use your unit circle. And don't give me a decimal, because if you do, it's wrong. Sine of pi over 4 equals cosine of pi over 4 equals, and tangent of pi over 4 equals, this is square root of 2 over 2, square root of 2 over 2, and 1.
Wait, pause. Oh, I did all 6. I'm just an overachiever.
Oh, you are just an overachiever. There you
okay,
go.
hold on.
I'm halting. This is 76.
So what we do is we go with pi 4 and we just put those numbers in. And
Yeah. Yeah. Sine is the y coordinate, cosine is the x coordinate, tangent is there. Yep. So just a heads up, if I say without using a calculator, you can either do it in your head or you can use your unit circle. Like that's what means without a calculator. That's what without a calculator means. Okay? 80 would be the next one, but we cancel it. So we go to 84. Use a calculator to evaluate the trig function. Round your answer to 4 decimal places. Oh. Now, normally we don't have pi over 7s on our unit circle anyway, so it wouldn't help to get a coterminal angle, right? Like to add 2 pi.
So you just punch
Okay? So you just punch her in. But, yeah, we do have to do 84.
I forgot how to shift it.
We don't have to do 80. We have to do 84.
You have to start to a radian.
I'm just kidding. How do I make it radian?
25 pi over 7 is a radian, so you want to be in radians when you do it,
How do I
okay?
make it radians?
Second mode, or setup. Then hit the number 4.
Tangent 25.
Okay.
Where's my
Okay.
pi? I can't find my pi button. Oh, there it is. Pi.
Divided by 7.
Whoa.
4 decimal places. Negative?
Negative 4.3813.
There you go. Yep, it has to be in radians because the only thing you have to worry about being in radians versus degrees. If you're just doing simple math like 2 plus 2, you don't care if you're in radians degrees. The only time it matters to be in radians degrees if you are taking sine, cosine, or tangent of something, right? Sine, cosine, or tangent of something. And whatever you're doing, you want to make sure that whatever's inside of here is radians versus degrees. That's what your calculator needs set in.
I just got
Okay?
positive.
Good?
The test isn't gonna be this long, right?
Did you do, no.
Hey,
Did
yeah,
you do negative
yeah.
25
Yeah, I used
pi
to
over
say
7?
Positive, it is.
Yeah?
Yeah.
That's fine.
Good?
Even
Good?
if it comes out negative, it's positive.
Us two messed up. Or two
No.
messed up.
It's,
Wait.
it comes out whatever it comes out. It's supposed to be negative.
I got positive though.
It's positive.
It is positive? Okay, then Marcus messed up.
Well,
Okay.
how? It's a positive, because I got a negative.
I didn't put negative 25.
Oh, I didn't put negative 25 either.
Yeah, it should be negative.
Sillies.
Alright, 88.
Okay, good?
Nope, 92. Nope, wait. Yeah, we have to do 88.
We gotta do 88. 88. But we don't have to do 92. Yay! We have to graph 88. Blah, 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 blah.
Why
88.
is the 8 cosine of negative?
Alright, so let's talk about things here. Let's talk about amplitude.
Oh, we have to do that?
Let's talk about
Oh,
period.
no.
Do we have to graph it
I
right?
am toast.
Yes.
Because I don't remember.
Phase,
Today.
shift, vertical shift. Okay. Alright, so I have an 8 here. That means the
Up
Amplitude
8.
is 8.
amplitude is 8. It's not up 8.
Oh,
It goes up to 8. Yes. Okay. All right.
The period is 2.
I'm not doing plus anything on the edge here, which means I have no vertical shift. And inside those parentheses, phase shift, I have nothing, right? So I'm not shifting left and right, not shifting up and down at all. Okay. This is negative 1/4 x. Correct?
Why did they put that like that?
Negative
How does
1/4
that
x.
should be
I don't know. Negative x over 4, negative 1/4 x. Okay. So the b value is negative 1/4. Okay. Cosine, what's cosine's normal period?
1. No.
2 pi. So I take 2 pi and I divide by
1/4.
1/4. I'm just going to do 1/4.
Pi divided by 1.
If I times it by 4 over 1, 8 pi. So I'm making it wider, right?
Isn't it negative though?
But period technically is like a distance, so it's
Oh,
never
so they
negative.
don't care.
Okay, now that negative is actually, I won't give you a negative inside of the parentheses on the test, FYI. But this negative is flipping it over the
Why?
y-axis.
But that
Doesn't do
really
nothing.
change it, right?
Now, cosine normally looks like this, right? And it goes like the same on this side. So if I flip it over the y-axis, it's the same. So that negative really does nothing to it. Does that make sense?
Wait, you
Okay,
put
for
it
cosine.
Y.
For cosine. Over the y, that's x, that's x, that's x. X, if it's flipping it over the x-axis, it would be a negative in front of the 8. Does that make sense? That would be over the x-axis. The y-axis is going to reflect it like this way. So this chunk's going to go over here, this chunk's going to go over here, which will be exactly the same. If it's cosine. If it was sine, it would change, right? Like sine does this, right? And if I flip him, like this chunk's going to come over here and actually be like here, right? It's going to go this
So it's
way.
going to be like if it's negative.
Right. If it's gonna be like if it's like for sine, since it's an odd function, since sine is an odd function, a reflection over the x is the same thing as a reflection over the y. Does that make sense?
Yep.
Yeah. Okay. Because that's sine. All right. So cosine. All right. Let's graph him. So we are not shifting him at all. So I really just graph him and then I label stuff. Okay. So like here's my top, here's my bottom. Cosine does. Like starts here, ends up here, down here, here, and here, right? He does like one of those, right? Except he ends over here at 8 pi. In the middle is 4 pi. If you want to label these, this is 2 pi. I'm not going to make you get this specific, but there is that. 6 pi. He goes up to 8 and down to negative 8. And there he is. Okay?
Doesn't matter. Can you have it flipped on the other side? Will
You can graph it on your calculator.
Can you?
Yeah.
You just found that out.
What?
That's why
It's
I
called
wish
a
Marcus
graphing
still had his
calculator.
graphing
You
calculator.
can
but
graph
we have to give
cosine
it
and
to the
sine
big
on here.
kids.
That means I don't even have to do this. I can just look on here and find out what it
When you're
is.
ready, I'll just throw it across.
You still have to have your units right. I mean, like.
No, because it gives you all these
Yeah,
things.
it'll tell you. Wait, let me.
But your units will be in decimals, and if you give me it to be in decimals, I'm gonna be very angry.
Will you?
Okay,
Wait.
can we
I
just
will.
keep going,
I will.
please?
Wait, what is the?
I'm
Wait,
gonna
hold up.
take a graphing calculator.
8 pi, which should be like
We
20.
don't have to do
7 point
92.
Okay.
Wait, hold up.
No 92.
Zoom out.
Just 96.
96. Sketch a graph of the function. Tangent. The only thing that's happening to tangent is this pi over 2. So let's talk about amplitude. What's the amplitude of tangent? Tangent technically doesn't really have an amplitude, but the number in front of tangent is 1. So he's like over 1, like over halfway up 1, Period. What's the period for tangent?
1 pi.
Pi divided by b, but b is the number in front of t, which is 1, so it just stays pi, right? Okay. The phase shift. You remember the formula for finding phase shift?
Negative c over b.
Negative c over b. Okay. So negative c is negative pi over 2 over 1, which is negative pi over 2. So it is left pi over 2. We'll mark it. And vertical shift, there's none. Okay, so we have to graph. We don't have to graph 100. Oh, 96. This is the last one. Hey. Okay, hold on.
No,
Well,
so
of
we
the
like
of the 4s, right?
3 more. No, we have so many more.
We don't have
You
to.
gave us so many problems.
Hey,
Just
girl,
kidding. I'm
we are
kidding.
literally doing them together.
I'm kidding. I was just
Wait,
kidding.
wait,
It was
wait,
a
You
wait,
know.
hold up.
It was a joke, amateur.
Wait, so the amplitude is 1, the period
Is pi.
is pi,
Which means it only goes pi over 2 on each
phase
side.
shift is
Right?
left,
You don't have.
What is
pi over
Okay.
2.
So I'm gonna start.
It goes
Yeah.
I'm gonna start
Yeah,
with left pi over 2, right?
Do we add to both sides?
Normally tangent does this. It goes. Does it go uphill?
Oh.
Yeah, it goes uphill like this, right? And this is pi over 2. Yeah, pi over 2 and negative pi over 2, right? Okay. So now I am shifting him over pi over 2. Okay. But what's happening at this negative pi over 2?
He's going.
Is there a vertical asymptote there?
No.
Yes, there, well,
The
not
center
anymore.
dot
Not
is
anymore.
now
Yeah.
there. The center dot is now there, right?
Yep.
Yeah?
So now the asymptote is 0.
There's an asymptote at 0, and there's an asymptote at
Pi over 4.
Pi over 4. Negative pi over 4.
no.
Negative pi over 8.
No.
Oh,
Negative pi over
Negative
6.
pi. Negative pi.
Negative pi?
Yeah.
Right.
Yeah.
I don't like math. This is hard.
Sure.
What time does Skirts play tomorrow?
Oh, at pi over 4, negative
It's
pi
a
over 4.
night game because
It's at-
Jake's gonna streak.
1,
Oh yeah.
Really?
and at negative 1.
Oh yeah. That one.
If they lose, he's gonna streak across the field in his undies.
Wait, which Jake? Hodson or Boniface?
Boniface.
That's a
He
lie.
gets $300 if he does it.
Who, did that?
Me, Kiara, and Gracie are all chipping in. He's gonna take his ID out of his wallet, give it to his girlfriend. He's like we're sitting in stats, and he's sitting here. He's going, okay, what are my consequences if I do this? He's like, will I go to jail? And we're like, no, they'll just throw you out. It'll be fine.
But if they wanted to, they could get him for like public indecency.
Oh yeah.
He's in his underwear. He's fine.
Yes, but if
He
they
goes,
really
and then
wanted to.
he goes, well, if the security guards can't get me, and then he goes, well, if the players are out there, and he goes, I'm not worried about Nebraska because they can't tackle, but you know.
Wait, Jake is gonna go across.
Okay, questions about 96, are you still labeling? Are you
Wait,
doing
can you
okay?
go up again?
Yep, he's gonna run out.
Okay, what's the next one?
Wait, can you
Run
go up to
across and
90?
run back up.
88?
As, our coaches would be? Especially if you got,
The orange one is 88.
It's not
Okay.
happening.
I know.
I hope
Rachel's
he
probably
does
just
it.
having a blast over there.
They won't let you down onto the field.
He will get down there.
No.
He
They
will
won't. They
get
have like
down.
security guards at every like.
They're fat. They can't catch box head.
They're not that fat, actually.
Yeah, they are.
No, they're not.
Yeah.
Anywho. Okay, which one's next?
108.
108. Okay. All right. Evaluate the expression if necessary. Round your answer to 2 decimal places. How do you do arc sine of that thing?
Put
Negative.
sign to the negative one.
Is this thing? Okay, so here's the deal. Here's the deal. Here's the deal.
Is what it-
Arc sine means that sine of something is 0.213. Do I want to be in radians or in degrees?
Degrees. There's no pi.
There's no
That
pi.
doesn't matter.
Radians.
We don't know.
Degrees. I don't know.
The answer is whatever you want your answer to be in, right? It's going to give me the angle as soon as I solve for it. So, do I want my answer to be in radians or do I want my answer to be in degrees? Because I'm solving for the angle, right? Okay, so let's do both, just so that we know.
Oh.
Degrees, radians. I will specify which one I want. Okay, so degrees, radians. Degrees. Somebody have the radians. Do radians first.
Degrees is 12.3.
12.3. 12.3 degrees.
And then radians is
Like 0.0 something.
arc sine of 0.213. 0.214.
Okay.
0.215.
0.215.
He's having a seizure.
Do you know how many degrees
The
one
muffin
radian is?
man, the muffin man.
Do you know how many one radian?
Who's having a seizure?
You.
The
Do you
guy
know how
from
many degrees one
Kennesaw
radian
yesterday
is?
was having a seizure.
Do you know how many degrees one radian is?
1 radian is
57 degrees ish, right?
100
So if I have
125.
only 12.3 degrees, that's like a fifth of a radian. So that
What?
seems
But
appropriate.
no facial hair.
I don't even know what's going
Oh, I
on.
don't
One
know.
radian is 57 degrees.
The one
So
that
if you're
got
trying to
10
approximate that, there's that. Okay,
The one that
108,
got 10
next one.
yesterday or no?
What's next after 108?
The one that got 10
112.
yesterday or no?
112.
Easy peasy.
Well, he used
But
it on
that's
the
in a
first
different
Saturday,
section.
so I don't-
112. It doesn't matter.
But there's
Wait.
one that has facial
Four,
hair.
is
one per section
the
only
cosine
applies to
that?
whatever. Okay. So this one says evaluate the expression without using a calculator, which means
Where's the cosine at?
which means
It's on your thingy.
use your unit circle. Okay. So this is saying cosine of something is the square root of 2 over 2. Now, there are two places where cosine is the square root of 2 over 2. Where are they?
There and there.
Pi over 4 and, hold on, don't tell me, 7 pi over 4.
Yep.
Okay?
7 pi over
But
4.
inverse cosine only
Only
lives in the
first, so
first
pi
and
over
second
4.
quadrant. 7 pi over 4 is in the fourth
no,
quadrant.
No, cosine.
No.
Cosine?
Cosine is wait, hold up.
Cosine, inverse cosine, is first and second quadrant. 7 pi over 4 is the fourth quadrant.
So it's a
What's the question?
first quadrant. We're looking in the first quadrant, right? Yeah. Okay.
I listed both answers, and I said, but cosine has to be in the first or
First
second
quadrant,
quadrant,
so it has to
and
be
the
pi
only
over
one of
4.
those answers that's in the first and second quadrant is pi over 4, which is in the first.
Next.
7 pi over 4 is in the fourth
116.
quadrant, so it doesn't work. Right?
116.
116, arc cosine of. Use the calculator to evaluate the expression. Do you want your answer in radians or degrees?
Degrees.
Let's do both.
No.
I like
Radians,
way
degrees.
better.
I'm just kidding. We can do both if you would like to, Mrs. Conacher.
I will specify which one I want on the test.
95.
152.6 degrees.
152.6 degrees. Okay, no. 156.2 degrees.
152.
No,
Nope.
152.6.
152.6. I'm dyslexic. I don't know. 152.6 degrees.
And I'm the
If
one with
one-
the learning
If
disability.
1 radian is 57 degrees, we are about not quite 3, correct? 2 point something. What do you got for radians?
What?
What did you do?
Point.
I took cosine. The arc
Oh,
cosine.
2.67.
I did.
2.67 radians. That seems appropriate, correct?
Yep.
If 1 radian is 57 degrees, 52 degrees is not quite 3 of those. So 2.67. Yes, that seems appropriate.
128.
128.